Alright, this is a video for Algebra 2 for section 1.3, which is on solving equations. So, more or less this should be review, but it's really important review. So let's get started. This document that you see here is something that you can print out if you go to the Algebra 2 folder, or I should have linked it for you in the weekly checklist. Okay, so first let's go over some vocabulary. So when you print it out, before I get started, when you print it out, don't print it out double-sided if you can. Print it out one-sided, so two pieces of paper. If for whatever reason you cannot print this out, then you can just take notes on the important concepts, but it would be easier for you to print it out. Okay, so vocabulary and concepts. First we're going to look at the properties of equality. Let A, B, and C represent real numbers. So we have A. If A equals A, you have something called, you may remember this from geometry, the reflexive property. Something is equal to itself. Okay, if we have A equal B, then B is equal to A. This is also something from geometry. This is the symmetric property. Okay, if A equals B and B equals C, then A equals C. That is the transitive property. So these three are very often used and taught in geometry. Okay, next, if A equals B, then B may be substituted for A in any expression to obtain an equivalent expression. That's the substitution property. Okay, next, the other properties of equality that we have here. If A equals B, then A plus C equals B plus C. So we have this C that we're essentially adding to both sides. That is the addition property of equality. And then we're just going to go down the line. See, we're subtracting C from both sides. That's the subtraction property of equality. We're multiplying C to both sides. That's the multiplication property of equality. And if we divide by C to both sides, assuming that C is not 0, since we cannot divide by 0, then we are doing the division property of equality. Okay. So now we're going to be solving equations. Equations have to have an equal sign. All right? 2x plus 3 is not an equation. That is an expression. You cannot solve it. But as soon as I make this 2x plus 3 is equal to 5, then I can solve it for x. You must have an equal sign for an equation. Okay, so the solution of an equation is the value that makes the equation true, more or less. So for example, the solution to this equation is 1. X equals 1, because if I substitute it in, 2 times 1 plus 3, I get 2 plus 3, which is 5. It makes this true. So 1 is a solution. You may recall that equations can have no solutions if there is no number. A good example of that would be x plus 3 equals x plus 5. For example, there is no number that when I add 3 to it, it will be the same as that number when I add 5 to it. It just does not work. This would be a case of no solution. There's also the case of every solution. Well, not every solution, but an infinite number of solutions. For example, if I give you the equation x equals x, give me a number, 2. Does 2 equal 2? Yes. Okay, but that's not a unique solution. Any number you could have given me would have worked. So there's variations. Okay, so Here is my method for solving any equation. First step, simplify both sides. This may or may not be needed, but you have to check this first. And to do that, first, do any distribution, and you want to do that first. Second, combine any like terms, okay, in this order. Again, this may not happen at all. Okay, step 2, get all variables onto the same side. So if you have x's on one side and x on the other, then you want to get them all onto the same side. By the way, I should say like variables. Okay, usually what we're talking about here when we're solving an equation, we're talking about a one variable equation. Although a lot of these principles can apply to equations that are more complicated. All right, moving on. After you've done that, you want to determine what is happening to the variable and in what order. This is a little weird. I'll show you and it'll explain it. Next, undo what is happening to the variable using opposite operations in the opposite order. Okay, you'll see. All right, I got two equations I'm going to show you. They're not super simple because I wanted to show you all of the steps. Okay, so step 1, simplify. Step 1 of that, do any distribution. So distribution, right, you have something in front of parentheses that needs to be distributed to those parentheses. So -4 is going to multiply times -x. -4 is going to multiply times 5, right? And notice I said this is a -4, not 4. You got to think of subtraction as negatives. Okay, so I'm going to do that, and I'm going to leave the 2x alone. -4 times the -x is a positive 4x, right? Negative times a negative is a positive. -4 times 5 is a -20. There's nothing to distribute over here, so I'm just going to copy this. Math is all about neatness. Okay, next step. Combine like terms on each side. 2x, 4x. Those are like terms, right? -20, not like terms. So when I say side, I mean side of the equal sign. This is one side. Over here, this is another side over here. So I'm looking at here and I'm saying, what can I combine? I can combine 6x, and I can't combine the -20, so I'm going to leave it alone. I can't do anything over here. Those are not like terms. I'm going to leave it alone. Okay, now I'm on step 2. Get all like variables onto the same side. I've got a 6x here and a 5x. I need to get those onto the same side. And in this case, I need to use opposite operations, right? If you move anything from one side to the other, you have to use opposite operations in order to move it. Okay, so what I'm using here is either the addition property of equality or the subtraction property of equality. See, I have 5x. I'm going to move the 5x. You can move the 6x, but my habit is to move the smaller things because it results in less negative numbers that way. Okay. Now, the reason we use opposite operations is so things cancel, because 5x minus 5x is nothing. That's going to move it. 6x minus 5x is 1x minus 20 equals 3. Now, we don't really have to write 1x here. So 1 times x is just x, so I'll erase that. So now we're looking at undoing what is happening to the variable and in what order. Usually at this point you might have two things happening, like something multiplying and something subtracting. Because I just have an x here, and it's subtracting 20, I only have one thing that's happening, and that is subtracting 20. So what's happening? Well, one thing is happening. I'm subtracting 20. So to undo it, I have to add 20. So that's the next step. Undo what is happening. Use opposite operations in the opposite order. I'll show you the opposite order thing in a bit, because this doesn't apply here. But I'm going to add 20 to both sides, and I get my answer x is 23. Okay, let's do that again. Step 1, distribute. I have two distributions here. First one, I'm distributing a 3. Second one, I'm distributing a negative. So distributing a 3, I get 3 times x is 3x. 3 times negative 4 is negative 12. Copy everything else verbatim on that side. So just plus 5x. The 4, not doing anything with it. I'm only distributing a negative. Think of it like a negative 1. So I'm distributing a negative 1. Where'd my 1 go? There it goes. To the parentheses here. Negative 1 times 2x is negative 2x. Negative 1 times 7, negative 7. Okay, combining like terms. What like terms do we have? I see we have on this side 3x and 5x. Those are like terms. I also see on this side we have a negative 12, but I don't have anything else. That's this side. So the only thing I can combine is the 3x and the 5x, which is 8x. So I'm just going to copy the negative 12. Remember, I'm only looking at one side at a time. You can't combine all the way across, right? They're on different sides. Okay, what can I combine here? I only have one negative 2x, but I have a 4 and a negative 7. Those are combinable. So that gives me negative 3 minus 2x. Okay, now I'm on step 2. Get all like variables onto the same side. So my variables are 8x, negative 2x. I'm going to move 1 to the other side using opposite operations. I like to, if I have a negative thing, I like to move that one. Then I'm going to add it. That's opposite from subtracting. So they'll cancel. Cancel, cancel. We get 10x minus 12 equals negative 3. Okay, now I'm going to really show you what I mean in this one, because in this case it didn't really happen. When I say define or determine what is happening to the variable, here's x. What's happening to it? Well, first, so what's happening? I'll write down my thinking here. First, I'm multiplying times 10. X is being multiplied times 10 first. Think order of operations. Multiplication comes first. Second, I'm subtracting 12 from it. Okay? That is what's happening. And in what order? That's step 3. Step 4 is we are going to undo it. Okay, we have two things now. So we have to pay attention to the order. We have to do it in the opposite order. So I'm going to undo these things in the opposite order. So the first thing I'm going to do is undo the subtracting 12. So you add 12. Second, I'm going to undo multiplying times 10. So I'm going to divide by 10. Although we don't really use this symbol, we just write over 10, right? So let's do that. I'm going to add 12 to both sides. Right? We don't divide by the 10 first. We add the 12 to both sides. We get 10x is equal to 9. Now we're going to divide by 10 to both sides. You probably already knew that, but I'm explaining my process. If you have a fraction, does 10 go into 9? Nope. That's okay. If you have a fraction, you could leave it. Just reduce it. But 9/10 is good, so we're done. Okay, that should have been more or less review. If that was a little fast, you might want to look up some more resources on solving equations to help you out. But I really suggest just following these steps and you'll be fine. That'll work for just about any equation, though it's one variable, okay? Step 2, solving for a variable. Now this is where we have equations with lots of variables, like formulas, and we're going to rewrite them into one, so it's equal to one letter. Okay, so solving a formula for one of its variables. The formula for the surface area of a rectangular prism L units long and W units wide and H units high is this. So they give us this formula. Solve the formula for W. So what that means is we are rewriting the whole equation. So in the end, it will be W equals some stuff. So the L, the H, and the A will have to be somewhere in here. Okay, so one thing I like to do is identify where that W is. It's two places, here and here. So when you have it in two places, you're going to want to somehow combine them or maybe do a little factoring. Okay, so let me show you. First we have everything in parentheses and there's a 2 here. I would distribute the 2. So you get 2LW, 2LH, 2WH. So this is using the distributive property. And then what we can do is we have this term here that doesn't have any W's at all, this thing. Just get it to the other side. We don't want it. We're looking to get the W's alone, so just move that to the other side. So we're going to subtract 2LH, the whole thing, just get it out of the way from both sides. So if we subtract it from this side, it goes away. So then we're going to have to subtract it from this side. And so we get A minus 2LH. Okay, now that W. Now we only have the W things on one side. We have L and H's and 2's, but what's going to be easy now is we're going to factor or kind of do like the opposite of the distributive property. So you could think of this like also as the distributive property, but you may also think of it as factoring, where we're taking this W out and we're left with 2L and 2H. The benefit of doing that is now this ugly thing that doesn't have any W's, we can divide that from both sides. So we're going to divide both sides by 2L plus 2H. So divide it on this side, and it goes away. Divide it on this side, and we get our answer. So A minus 2LH on that side divided by 2L plus 2H. There's your answer. W's all alone. Okay, I'm going to give you one more example. We have x over a plus 8 equals b, and we're solving for x. So we're trying to get x alone. So this kind of works with the whole idea that I was doing when I was solving the equations here. When I was doing the undo what's happening to the variable. That works really well in this one. Here's x. What's happening to it? Well, first, it's being divided by a. Right? That's what's happening first to it. Second, we're adding 8. So this is what's happening. So we undo it in the opposite direction. So first, we're going to undo this one. So subtract 8. Second, we're going to do the opposite of dividing by 8, which is multiply by 8. Okay? Now, they didn't do it that way. And I don't know why. I mean, I guess they're still following the rule. Okay? What they're doing is they're doing multiplying by a first. That's fine in this case. As long as you multiply everything by a, it'll work. I like my way better. So I'm going to do my way, and then I'll show you theirs. Subtract 8, subtract 8. X over a would be equal to b minus 8. Multiply by a, multiply by a. Just multiply the whole side. And I'm done. Okay, I could distribute the a, and get ab minus 8a, and I'm done. Now, over here, they decided to do this first. That's fine, except they're going to have to do it a little bit differently. They're going to multiply everything times a. So everything times a, and you see the a here. These will cancel, and you get x, 8a, equals ab. Then you have to subtract the 8a now from both sides. So AB minus 8A. You get the answer, same answer either way. Now, notice here it says the denominator cannot be 0, so A cannot be 0. And that's because in the beginning, A was right there. Okay? There's a couple more examples for you. Why don't you give these ones a try on your own? We can check them in class. Okay? All right.